Hello everyone, welcome back to Virginia Tech Giving Day. For those of you who are just tuning in, my name is Marika Ottman and I'm your College of Engineering host for today. I'm a senior in aerospace engineering here at Virginia Tech, and thanks to donors like you, I've been able to do an internship abroad, I've been able to receive a scholarship, and I've gotten involved in really cool research and design teams like the one that we're looking at this evening. So just a quick update, the College of Engineering has raised $140,000 from 514 donors. So we have 16 hours left. Please donate. Every person counts and every dollar counts. Now to kick off tonight, we are in the RoboGrinder lab, and this team is top in North America for the competition that they do. They compete internationally, they go to China as well as Canada, right? And I'm speaking with team lead Ethan. So can you tell me a little bit more about what RoboGrinder is?
All right. So hi everyone. My name is Ethan. I'm a senior student in computer engineering. And so this is our team RoboGrinder. We're a student design team. We're established in 2016 under the help of ECE department and Dr. Bowman and Mr. Bob. At that time, in the beginning of our team, we only have 7 members, and right now we are a team with 69 active members. So what we do is we participate in different robotics competitions, including the RoboMaster Competition that happens every August in China, and also the ICRA AI Robotics Challenge that happens every May, and this year it will be in Canada, Montreal. So in our team, we have 4 different branches, including ECE branch, and mechanical engineering department, and also a social media branch, and also computer vision branch. So as you can see, here is the working bench of our ECE team.
Yeah, all right, let's go check them out. And if you have any questions, please post them in the comments. We'll be doing a QA with the team at the end. All right. Hey guys, so this is the electrical and computer engineering sub-team?
This is our ECE sub-team leader, Peter, and this is our member, Matt.
Great, so Matt, what is the role of this sub-team on the entire project?
So the electrical and computer team is supposed to use an embedded system to control all parts of the robot.
Wow, so what is an embedded system?
So when people generally think of computers, they think of something like this, but that's not really going to fit on a robot, so we have a much smaller computing device right here. This is a microcontroller, and we have one of those embedded in this robot, which controls everything from the servos that make the motors that move the robot, the gimbal that allows the robot to aim, and the friction wheels that allow the robot to shoot. Also, we have some sensors like armor plates, gyros, and LEDs, because LEDs make everything look awesome.
Oh yeah. So you guys are essentially building the brain of this robot? Like, it wouldn't be able to move without the work that you do.
Well, don't tell the other teams I said that.
all right, it's my secret as well as Facebook Live, but nobody will know, nobody will see it. Great, and Peter, what have you been working on up here?
I've been working on with these super capacitors.
Oh my gosh. Super capacitor, so what does that do?
So this is a super capacitors. What it do is to increase our robot speed. So in our competition rules, our robot has 80 watts power limit for our chassis, which means they cannot release our motor's full speed. So we add this one to our chassis. So the supercapacitors can store energy from the battery temporarily and release energy to the chassis when it's needed. So this whole thing is designed by our members, and we draw our PCB board, we design our PCB board, we solder all the things together, and we also have our RoboGrinder logos here on our PCB board.
Ooh.
And so each of the capacitors here is 100 farad. It is 100 farad. It's a really big number. So the whole capacitor can store up to 9,000 joules. That is equals to like a adult people jogging for about almost 4 hours.
It's like a marathon. Oh my gosh.
Yeah, the whole capacitor has like anti-reverse mechanism, anti-intrusion mechanism, and an emergency stop mechanism. So I'll plug it in and see what is. Matt, can you hand me the board? This one. Yeah.
It's really cool that you have the designs, even the team logo. So is this custom designed, custom made yourself?
Yeah, our team member designed the whole structure, the whole design based on, and also we actually sold it last year during the competition because our stuff is like a module. You can plug in anytime you want. So you have a robot, right? And you can just plug in and you have the power to run super fast. So it's like a product that can sell on the market.
So you sold it to another team, a competitor?
Yeah, we actually sold it we tried to sell it during the competition, but now the team were able to afford it because we use all the parts that we can find, the best part we can find on DigiKey.
And hopefully, thanks to Virginia Tech Giving Day, you'll be able to afford much more after this.
Yeah,
We'll get into that.
Because of the price, we're only able to manufacture 2 sets of it. But during the competition, we have 7 different type of robots that all need this kind of super capacitor on it. So if you guys willing to help us, please donate to ECE department.
Shameless plug.
Every coin help.
Speaking of which, Peter has it plugged in now.
Yeah, it has animation and a UI on it.
No way.
So,
Oh my gosh.
see, this is the voltage of the current supercapacitor has. It's all in Mandarin Chinese, and this is like how many joules of energy the capacitor has. This is the input voltage. This is the input power, output voltage, and output power, and it also can sense the temperature of the capacitors. Also on the bottom line, it says Virginia Tech is the best university in the universe.
Oh, I agree with that. That's very true. We need to get that on a t-shirt or something.
Because during the competition, most of our competitors are from China, so we wrote down that one in Chinese so everyone can read it. Virginia Tech is the best university in the universe.
Yeah, in case they didn't know.
Yep.
So now we've learned a little bit about the brain, what causes the motion. You told me about the gimbals, the sensors. Can I see a little bit of the action of what one of these robots can do? You said
Sure.
something about shooting.
Yes. So the main purpose, like the main goal for this competition, RoboMaster competition, is our robot shooting 17mm and 42mm projectile to the enemy's armor plate, which have pressure sensor in it. That's how you determine the win or lose for this competition. So as you can see here, we build this testing arena to testing our shooting mechanism. And this is our ECE member, Sam.
All right. Hey, Sam. So what is this facility that I'm looking at?
So this is our testing area for our shooting mechanism. So our ME team can use that for testing their newly designed gimbal. And for CV and our EC team, we can test our auto aiming algorithm and in different light conditions. And also because the projectile is launched in a very fast speed,
Yeah.
so we need this enclosure to make sure that no one gets hurt when we are testing.
Good. So it's a nice, safe enclosure with
Yeah.
consistent conditions that you can control for different testing scenarios. That's awesome. So can you show me a test?
Sure. So.
Oh my gosh, that was so cool. I'm glad that's enclosed. That kind of looks like it would hurt. You know, it reminds me of the days my brother shot me with his airsoft gun, and I don't want to be like that. But this is really great, and I know you have a sensor set up there that you've been aiming at. Your target is number 4, but that looks like the same plates that you have on your robot. So in competition, would that actually be moving when you're trying to shoot it?
Yeah, in competition it will be moving, and our EC team and CV team is developing like the Kalman filter to estimate the moving target, so we can shoot when the target is moving.
Wow, that's incredible, and I imagine that takes a lot of work because I know I wouldn't be able to shoot it while it's moving, just myself as a human being. So being able to program something else to do that is fascinating. And so seeing some of their models and the motherboard, and now I'm seeing it shoot, seeing the whole part together, that's amazing. I mean, this robot is not simple. It's very complex, and I'm sure there's a lot that goes into it. So do you have a manufacturing team that puts this all together?
Yep. As I mentioned, we have a mechanical engineering team that they're located downstairs.
All right, so let's go check them out. And as I try not to fall down the stairs, please put any questions you have in the comment section below, and we'll be answering that at the end of the Q&A.
So as you can see, that's the area we have, and actually you can see it's pretty, the distance between each table is pretty close, because this is the best place that we can find. It's provided by Dr. Leon Nasa from ME department, and we really appreciate it. But since we are to have a real like 1-to-1 ratio size arena, it will be really helpful to us. So we also need some more space. So please help us and please donate to ECE department. So in our team, I think that's one of the best benefit that our team can provide to Virginia Tech is we welcome any student from any department with any technology level. For example, in our mechanical engineering branch, we have actually 2 sub-teams. One is called machining team, one is the design team. So if you're a freshman and you want to join a design team, you want to work with robot, but you don't have any previous experience with how to design the robot, how to draw the CAD, no problem. So in our team, we provide mentorship. So our older members will, based on using the Freeze Lab, they will teach you how to draw 2D CAD, 2D CAD file, and using the laser CAD to cut the parts for the design team. And after you are familiar with 2D modeling, then you upgrade it into 3D modeling and do 3D printing job for our design team. And then after that, you know how to draw 2D CAD, you know how to do 3D CAD. And at the same time, you know more about the computation, you know more about how to design the robot, because you are helping the design team manufacturing those parts. Then you will be able to join a design team and starting designing a robot. And also at the same time, you will have a more, general idea about what kind of job you're gonna do when you graduate as a mechanical engineering student, and you will know if you're really gonna like this job.
It's amazing. Do you have underclassmen here?
Yes. So this is our CNC machine, and we have it here. This is our freshman Frost.
Hey Frost, so what are you working on over here?
So what I'm basically doing is my teammates give me the DW file of the parts that need to be CNC'd. Then I need to convert that into G code, make sure the machine knows exactly what to do. Then after the progressing, I need to stand beside it, make sure everything's working, like nothing's caught on fire, the drill bit is working, the spindle speed is okay.
Yeah, and so as a freshman on this team, what's the most valuable thing you've learned so far, do you think?
Well, I think is I got a chance to learn exactly how to do like machining part, like because it's pretty rare experience.
Yeah, absolutely. And I know there are some programs, universities in the country where engineering students will graduate without ever doing this hands-on work in manufacturing. And that can lead to what we call ivory tower engineering. You have engineers that are making designs that are not actually buildable because they don't have that connection. They don't know what actually goes in to manufacture it. So it's really great that you're getting this experience now so that as you go on through your studies and you get more the theoretical side, when you put it together and create designs, you know if they're realistic.
Yes.
Wow, that's amazing. Now I see a bunch of hardware behind me, and it's my understanding that you have a whole family of robots for this competition.
Yes.
So could you walk me through what each one does?
All right. So in this area is actually the design team for our mechanical engineering part. So we separate into different tables based on the type of robot. In the competition, in the RoboMaster competition, we have several different type of robots, including the infantry robot, the engineering robot, the guard robot, and the hero robot. So this is Joe. He's in charge of designing the infantry robot.
Wow, yeah, Joe, can you tell me a little bit more about the infantry robot?
Yes, infantry robots, as you can see, relies on the turrets that shoot this type of bullets. As you can see, this is 17mm bullets.
Oh yeah, that's small and painful.
And this type of feeding mechanism can reach 10 rounds per second, as you can see on top. And this is the most active engagement that the infantry will be against other robots. As you can see, we also have a different type of structure than the other robots. We have body on frame robots that depends on rigid structures that can take impact from others without breaking apart. And we also enhance the joints between all those structures to avoid collisions.
Wow, and I see this robot in this stage looks a little different than some of the others that we see laying around. What stage would you say you're at as far as the building process?
We just finished our prototyping, so we just change. As you can see, we change from a more fragile material to aluminum, which is more stable, and it can enhance this the stability while the machine is running around. And also, we just finished our turret design. It's ready for use. And once we finish replacing all the material, then we can actually begin testing.
Yeah, and I noticed you said that this was a more fragile material, so you've since upgraded and improved upon that. I also noticed there's a lot of wood hanging around, and none of your robots are made of wood.
Yeah.
What is that for?
So because we are a little bit tight on our hands, so when we do prototyping, first we actually use cardboard. So if you have a drawing, a CAD drawing, and you're not sure if these two parts gonna able to assemble together, we use cardboard. Then after cardboard, if that part is in a really weird shape, like if it have a hole like cross through it, then we use 3D print part. Or if it's a simple like 3D part and have holes vertically, then we use wood board and use a CNC to cut it out. This is like we can spend the lowest price to get our model done. Then after that's probably the second prototyping. Then when we move to the third prototyping, we use fiberglass. And this kind of material is cheap, but it have the same strength as carbon fiber, sometimes as aluminum, and we use that as the third prototyping. Sometimes we have this kind of material on our like finished robot. And then when it comes to the last generation, the one we're gonna use in the real arena, we change it into aluminum parts.
Wow, and so, like you said, a lot of iterations, a lot of redesigning. Joe, what would you say is the biggest challenge that you've had with making this robot?
So the biggest challenge of have it's not designing the robot. It's actually while you're testing it. When you actually design a robot, and when you test it, something fortunate happens. For example, some part that you think is gonna be the hardest and fall off, and some part it doesn't just hold up, and some part doesn't work as intended to. So what I do is I think the most hard part is to accept that something bad will happen and just make progress for that.
Yeah, accept failure and use it to strengthen your design. And I know classroom knowledge, they give us the theory behind it, and we can use that theory to kind of predict performance, like let's say how a robot will hold up in testing. But how much of the classroom knowledge comes into play when you're doing this versus experience that you get over the years while being on this team?
So I think the classroom knowledge is one of very important parts, but the robot design is more based on experiences. Though we will use force analysis and impact analysis on each part of the robots to make sure that it won't fall off and it won't break, but the most important thing is what you learn from previous experience, how you perform, and what should be improved on this.
Yeah, that's incredible. And that's what I think design teams are all about, is learning how to fail, because in the classroom there's a right answer and a wrong answer. But in these design teams, I know also in my own experience, you think you've made something that should work, but in reality it doesn't always work. So having those experiences, like you said, can make you a better engineer before you've even graduated. Well, that's incredible. So let's move on to the next member of this robot family.
Okay, so next one is our engineering robot.
This is a big one.
Yeah, in the RoboMaster competition, engineering robot is more like a doctor. So here's our member Viking.
Viking, tell me all about this robot.
Okay, here's this robot. It's not only a doctor, it's also like a supporter, ammo supplier, because as for the treasure island, they're gonna be the 9 + 6 ammo box on top. And because our hero robots is no longer able to get on the island, so this is the only robots can get on the island and get the ammo for the hero one.
So you have two robots that are working together.
Yes.
And, oh my gosh.
Yes, and I'm currently working on this mechanism. As you can see, there's a pole by the treasure island. It's a pole we're gonna use to climb on the island.
Is it that big red one?
Yeah, the right one.
It's not in the right place, but it's built in the right shape.
Oh, and so this whole stage here, are you guys trying to mimic what the conditions will be like in competition?
Yes, and actually our engineering robot's gonna climb on the island from that side by using that pole.
Oh my gosh.
And actually, this is the mechanism we built to help the robot to climb on, to grab the ammo box, which should be right over here.
Wow.
9 boxes in a row right over here, and 6 boxes on the top on a small table.
And so as time gets closer to competition, are you guys going to extend this arena until it's almost an exact replica of competition?
Actually, this is exactly the same size.
It's perfect,
but it's half of it because there's
we don't have enough space.
Yeah.
Like you can see the
wow.
edge of the treasure and where the pool is located is like the edge of our working space. This is our working space.
And here's one of the ammo box we built. It's 3D printed by 3D printer, and see the you got a golf ball. And actually, this golf ball is the same size as the ammo we got.
Okay, so the golf balls are a little bit bigger than those
Yeah.
pellets. So
If-
this
if
robot
you-
picks up golf balls.
Yes, if you like, excuse me, like
Yeah.
grab 2 ammo over here. This
Ammo.
Yeah, they're gonna be
Golf balls.
over
Golf
20 over 20 golf ball inside of this. And actually, this is one of the member. He's building the grip to help to grab the ammo box, and
And then it lifts it up, or?
yes, like that. Exactly the same way to work as that, and to pour into our ammo box right over here. I'm actually building it.
Wow. And so
And-
this one collects the ammo, and then it'll hand it
Collects
off
the
to
ammo.
another robot.
Yeah, because Hero Robots is no longer able to get on the island, as I said. This is the only box we got to collect the ammo. So it's very, very important in this season.
Yeah.
And actually, it's working like that to grab the pole. And as you can see, there's 2 large linear actuators over here, so it can lift it up to 1.2 meters.
That's incredible. And how does it pass off the ammo to the hero robot, which we will see shortly?
See the door right over here.
So the door okay, so the door opens, then it'll slide into another chamber on the hero robot?
Yes, it's cardboard, like Yiping says, it's like a prototype.
Okay.
So there's a door over here. This ball gonna stay on the treasure island, and the hero robots, as you can see on the top. This cockpit on the top.
Yep.
To collect the ammo, we open the door, ammo pour out into the hero robots, and here we go.
Okay, wow, incredible. Ethan, what's the next robot on the list?
So the next one will be the Gar robot. So this competition is like Dota or League of Legends. On each side, you have a base robot. Actually, this year the base robot is provided by DJI, like a animation. So it's a robot with several armor plate on it, and the whole mission for this competition is you destroy enemy space robot, destroy the crystal. So, but the crystal, the base robot is just a steady stuff there. It won't able to protect himself. So we have to have something called a guard robot. There will be a rail that in front of the base robot, and the guard robot is something hanging on the rail. And this robot is not like what we saw before, the infantry, the engineering robot, they are manually, but the guard robot, this one is full autonomous. It should have the ability to move by itself and will rotate it 360 all the time to try to find the enemy based on the color on their armor plate, and detect the enemy, locate the enemy, and shoot it, and hopefully destroy it in front of our base and protect the base.
So, for example, if a competing team, their sensor colors are blue,
Yeah.
then you would tell this robot, find and destroy any blue sensors.
Yes.
So then this robot will track based on that, all by itself.
All by itself, yeah, and all based on our computer vision team's work, it will able to detect the enemy and locate the armor plate, and based on how big the pixel is, to determine how far is it away from the guard robot, and calculate a projectile line and use Karman filter to chase it and shoot the projectile and destroy the enemy's robot.
Wow, that's amazing. And last but not least, can we check out the hero robot?
Yes, this will be the hero robot, as in the mobile game like or League of Legends. And you have a hero, right? And this is a hero robot. As you can see, this one is huge. So the engineering robot is grabbing the ammunition box with 42mm golf ball and will dump it from the top of this robot and will go to the shooting mechanism. And for the 70mm projectile, based on the competition rule, it only provides 50 damage per round, but for the golf ball, it's 500 damage per round. So it can easily eliminate an infantry robot by 3 rounds of golf ball. So this one is huge.
And so when you say damage, do you mean this is based on the scoring system, or are you actually breaking the other robots?
No, so in this competition, it's not like battle ball or something. We're not allowed to collision into other robots. We're shooting projectile to the enemy's armor plate. That's the only valid place to detect damage. We shoot projectile, and the whole competition is based on the remaining health point of your base robot. So there are certain stages, like you have to kill one enemy's robot, competitors' robots in the beginning, and then you're able to shoot the base robot. But if you don't kill the guard robot in the beginning, then the base robot is still gonna have 50% damage buff. So every for example, this projectile, when it hits the base robot, it's only gonna detect 250. So the next step is eliminate the guard robot, then start attack the base robot. So that's basically like a workflow for the competition.
Wow, Absolutely. And I've been dying to ask this, but could I try controlling
Sure,
one of your robots?
no problem. So.
Oh my gosh, I'm gonna regret this. Okay, so this is a full-blown arena we've got going
Yeah,
on here.
we got several infantry robots. These are the infantry robots from our last year's competition. We bring it back, we fix it so that our pilot can actually training on this robot.
Oh, so you have a pilot.
Yeah,
It's not
so
me.
so on the real competition, we have 7 different robots, including 1 drone, 3 infantry robot, 1 hero, 1 engineering robot, and 1 guard robot. And except the guard robot, all the other robot is driven manually by pilot. And the pilot actually won't able to see the arena like what we do. They're like playing real FPS game. This is what you're actually gonna see during the competition. So we have a camera on the top of the barrel, and the camera will feedback the image to the control room. And for the pilots, they're actually gonna use this user interface. But since we don't have a video capture card, we have to separate into 2 parts. So you can see here. And yep. So this is you how to aim. You use the mouse. So our embedded system team, this is also part of their task is control the robot by using the mouse.
So this is what they're doing upstairs.
Yes,
Yeah?
this is how they make the robot move. So you can see they did a really good job on the PID tuning. As you can see,
It has a laser?
yeah, it has a laser to help you aim the robot. See, and how you shoot it is you click on R, turn on the friction pulley, and you left click.
Oh.
That's how I shoot. Have a
All
try.
right, I'm gonna shoot it. I'm gonna keep it. Oh, rapid fire. And that's like 300 points right there, right?
Yeah,
300
and
damage.
also sometimes the enemies, the competitors, robot may like stack on stairs or something, and that's a really good chance to like have a rapid fire on it. So we have a function called rapid fire. If you click Q, it will.
How many is that?
I think that's 7 rounds.
7.
So in that, besides the friction pulley, we have like a sorting mechanism, like a magazine. So that magazine can hold 7 rounds of 17mm projectile. So it will shoot it at once.
Can I shoot it one more time? Or you shoot it actually. You're the experienced pilot here.
Sure. Let me reload the robot.
Gotta get the good angle. Oh, there you go. No, not towards me.
Hold on. Oops.
So what happened? Is it a jam?
I think it's jam because during the competition, all those bullets are new and clean. But since we're testing it here, they're full of dust on it, so there are many dust that
Yeah.
glue down.
I didn't even think of that. And I saw earlier that you have some kind of control that can make it actually shake up the loading chamber. What is that?
So in the competition, sometimes, as I said, so there's a like sorting mechanism underneath the magazine. And when you do rapid fire, sometimes it rotates too fast and it's like hollow. There's bullet like on top of the sorting mechanism, but nothing in the sorting. So at the same time, if we click R, it will shaking the gimbal and make the bullet shake it and will go into the sorting mechanism.
Wow. And now I see this one's moving around. This isn't haunted, right? One of you controlling it? Oh, okay, got it. But I do know that you have robots that can move around completely by themselves.
By themselves, yes.
Can you show us an autonomous
Sure.
robot?
So this is, as I said before, we participate in different type of robotic competition. One is RoboMaster, another one is called ICRA AI Challenge. So in this competition, we need to build 2 robots that is fully autonomous. So here's our 2 members from computer vision team, Derek and Chen.
Yeah, right. So Derek and Chen, can you tell me about what the computer vision team is and what do you guys do? Because that's a whole new phrase to me.
Our team is the main job is to use the algorithm to control the robot to shoot the target, let me start for the competition.
Yeah.
The introduction is the chain part. This part.
So the ICRA RoboMaster Challenge requires us to build fully autonomous robots. So they need to move around themselves, engage with another team, and also able to launch projectiles.
Oh my gosh.
They also need to navigate an arena and also try to avoid incoming damages. So we use ROS, which stands for Robotic Operating System, to control our robots. It consists of 2 layers. One is called Autonomous Mobile Robot layer, and
Wow.
the other one is called decision-making layer. And Derek's gonna talk
Yeah,
about
that's
what
my job is tell you what's
All
about
right, Derek,
we
tell
are
me
doing
all about
now.
it.
Yeah, we are doing now for the just now for the autonomic mobile layers. We separate to 3 parts, and the first part is the localization part, and we use the AMCL, the adaptive multi-parallel algorithm. It's a little
A
tough
lot of
for me.
words, yeah, absolutely.
And for this part, we use the we use the radar to transfer the coordinate system and to tell the robot the positions and the pose of the robot in the real computations on the map.
Wow.
Yeah, it's very cool.
So it's almost like a GPS system. So that's how you track your
like you are in
location.
the car, you can tell where to move.
Yeah, so you know where you are.
Yeah,
Okay.
where you are. Yeah, you can if you have this Google Map, you can see the arrow, you know, the boat. Yeah, like this we tell the robots do. And the second part is for the navigation part. The first step is for the global path planning. For this part, we tell the target to the robot to where you should go. If for example, if you should go there, and we set the target, and the computer will compute, and we use the algorithm to get a path to this part.
Wow.
And the next step is very important for us and for our robot is the local path planning. We use LiDAR. We also use the LiDAR to tell the robot the surround the area.
Any obstacles that are close by, right?
Yes, I use a laser.
Yeah.
Yeah, it's
And
very.
so is it one of those things where you shoot a laser and the signal bounces back, and that's how you know there's an object there?
Yeah,
Wow.
like when you're working, you see the E-pins here. You will avoid him.
I guess I won't shoot them. Yeah.
Yeah.
Don't shoot people here.
And we tell the robots to avoid the wall and avoid the opposite robots. And for the third part is for the detection part. Is also the very important part. You can see they control the robot to shoot the target, but in our competitions, the robot will shoot the targets like this by themselves.
So this is the autonomous robot that's
Yeah.
just tracking number 5.
Yeah.
Oh my, and Ethan's controlling number 5.
I'm
right?
controlling
you're
number 5.
So is the autonomous one gonna shoot without being told, or
Yeah.
Yeah.
how is it?
This
But
one.
you guys are on the same team. You're both blue.
Yeah, they just changed the algorithm into blue.
This time we can kill the.
Oh my gosh! I think you go to the Olympics if it were a person.
Yeah, you can see the gamble is very smoothly because we use the timer feature.
Wow.
Some prediction to how the robot will do.
Yeah. Wow, that's awesome. So is this based on a
It's based on the algorithm.
So what is the algorithm for?
The algorithm is shoot and kill. Shoot and kill the robot is eliminated. So if the LED bar turns dark, it can be eliminated.
Yeah, this is around. Oh, there it goes. Oh my gosh. And so I see the blue blinks every time it gets hit.
Yep.
So that recognizes that it's getting damaged. Wow.
But right now we couldn't move the competitor's robot too fast because the computation power we have here is not enough.
Yeah.
But right now we're using NVIDIA TX2, and we hope we can change into the NVIDIA's new platform, which is Xavier. But that needs some help.
Funding?
Yep, some funding. So if you guys are willing to help us, and we need your help, I require help. So please donate to ECE department. Thank you.
All right, great, and that's a perfect segue into our end. Is I think we're gonna do some Q&A
Sure.
with the team members, if you could. So throughout this entire interview, we've had a lot of listeners put in and some questions that they have for you. So we have someone named Ross who wants to know: are there also mentorship programs for the computer and ECE branches?
Yes. So as you can see, Peter is actually a senior student. He's gonna graduate after this semester. But Matt is our new member. So they are like a pair. Peter is teaching Matt everything he know since the last 2 years from this competition, and Matt gonna handling all the tasks after Peter graduates. And also we have mentorship based on AMPLAB from EC department to teach soldering and also advanced soldering so that they can help soldering all our supercapacitors and also all, except the main control board, all the other boards we're using is manufactured and designed by ourselves. So we have hired members with higher knowledge with like Eagle, like how to design the PCB board, and they will teach our new member how to soldering each part on it. And at the same time, they will teach them why we design the PCB board based on our knowledge, why we make this wire this wide, this kind of stuff. So, and also for computer vision team, our our previous sub-team leader, Jason, he actually designed a course step by step. And also Frank, he's teaching C++ every week to our new members, help them get familiar with OpenCV, with all the algorithms we're using right now.
Wow. And I know there are some design teams that different engineering departments will recognize as senior design projects. Are you guys doing this for senior design, or is this completely extracurricular, voluntary?
So for our team, we were established in 2016, and at that time we don't have that much time working on how to make our team famous in the school. We were just working on building our robot, try to win in the competition. And fortunately, next semester, we're gonna become senior design for both IME department and EC department.
Congratulations!
Yeah. This is like a treat for our team member. They've been working in our team for 2 years without any credit hours. They just do this voluntarily, and they did quite a really good job. Last year, we got first prize in the international competition and third prize in the grand final. And also our team last year was representing Virginia Tech and got interviewed by Bloomberg from US, like NHK from Japan, and also Xinhua News from China. And also more excitedly, a DJI studio is gonna send a film team to us to film a production film for us this April.
Wow, so I get to meet all the famous people before DJI comes in. This is quite an honor for me.
Yeah.
So we have a more engineering question. How do you protect the electronics from being damaged by the projectiles?
Okay, so as you can see right now, this all these two we used to have so the main control board is on the back of the gimbal. So we have a acrylic board surrounding it to protect it. And for the full autonomous one, we have a LiDAR which is really expensive. Yeah. It's like $4,000, and we already tested to put an acrylic shield on the outside. And also we were hiding most of the supercapacitor. Is although when we design it, we have several mechanisms to protect it from failure and protect from damage, but we're gonna store it in between the frame, like the place where the most strongest place.
Wow.
Yeah.
So a big design consideration is actually the configuration of it, so that you keep all the most important parts stored
in the most pressure safe place.
And then if you can't, things like LiDAR will have a protective shield.
Protect shield. And also we need to test like the reflection rate because sometimes if we just simply put an acrylic sheet in front of it, the LiDAR will totally malfunction. All the laser will be reflected to itself. And also during our design process, this is the third prototyping. And when it comes to the fourth, there won't be huge change on the structure. At the same time, the ECE team gonna engage into our mechanical engineering design team, and they're gonna talk about, okay, we should put for example, the ESC here, the main control board here, and to figure out which place and how to wire it up. And also the ECE team gonna start wiring all our custom wire. For example, we need this wire to be just 10 centimeters long, so there won't be extra wires running around. So that will be the next step.
Wow, that's amazing.
Yeah.
We have another question. How old is this team? I know you talked about it briefly, but really put into perspective that you all not that old.
Yeah, we're not that. We just established in 2016, so we're like 2 years old. About 2 years old. We went to the competition twice, and this year, August is gonna be the third time we go to the competition.
Amazing. And then this is a fun one. Do you have any non-engineering students on this team?
Yes, actually, our team, the component of our team is variety. We not only have college from College of Engineering, but we also have students from architecture. They are helping us building the arena, and we have students from fashion design. They are in charge for design all the jacket, this jacket is designed by them, and inside we also have a team polo shirt.
I really want one.
We have 3 different uniforms, and also one for during the competition. That one it have they use a material that can dry really fast, so they can change it, wash it, and wear it on the second day. Because
Everything.
the competition is really intense.
Wow. All right, and then last question, and then I kind of want to see more robot action at the end. How much does it cost to build one of these robots?
So our annual budget is $50,000, and for building each robot is different. So for this kind of infantry robot, it's around $5,000, and for the hero robot, it's basically the same. The one we spend most of the money is probably going to be the engineering robot, and also the ICRA robot. It's around $6,000 or $7,000. But that's actually now the biggest place we spend our money. Since the competition is in China, and we try to build all our robot into a perfect shape, and to have it fully functional before the competition, which means we need to ship them all back to China in a whole shape. We cannot disassemble it.
Yeah.
But sometimes for the chassis we weld it together, so we cannot disassemble it, which means we need to ship it back to China and ship it back to US. Last year we spent about $5,000 for just ship it from China back to US, and it's come out of our own pocket. So we really need your help also on this part. Please donate to ECE department.
Yeah, absolutely. And being so innovative, with all of this innovation and competing on an international stage, that doesn't come without a cost, and like you said, you guys are so passionate about this that you've been feeding it out of your own pocket. But it would be great if efforts like Giving Day at Virginia Tech can help fund these amazing projects, because you guys need to get recognized for the work that you do. I mean, you're the best team in North America.
Yeah.
And that's why I'm so excited to be here. I was wondering if we could close out, watch some more battles between. Yeah,
No
I'm not
problem.
gonna shoot it, but let's.
Sure.
All right, and thank you all for tuning in again. Just check out some battle robots, and please donate. Go College of Engineering.
So our red robot just eliminates these two blue team. Yeah. And instead need to go into the arena to regenerate the AI one and also this one.
All right, well, thanks for the demo, guys. And just to close out, we'll do one more quick update. So right now, the College of Liberal Arts and Human Sciences, they're still in first place, but we're trailing close behind by 60 gifts. So every person counts, every dollar counts, and we need our engineering hoagies to get us back in the lead in the participation leaderboard challenge. So please donate. Thank you so much.